When it comes to chemical handling, personal protective equipment is often the first thing people think about. But PPE is also one of the most misunderstood parts of chemical safety. The wrong glove material, a poorly fitted respirator, or missing eye protection can turn a manageable exposure into a serious injury. In this video, we'll break down what type of PPE is required for chemical handling, how to select the right equipment for each hazard type, and why PPE should always be the last line of defense, not the first. What is PPE? Personal protective equipment refers to any clothing, device, or barrier worn by a worker to protect against a specific hazard. In chemical environments, PPE serves one purpose: to prevent hazardous substances from reaching the body. It does not remove or reduce the hazard itself. It places a barrier between the worker and the chemical. That's why it sits at the bottom of the hierarchy of controls, below elimination, substitution, engineering controls, and administrative controls. PPE fills the gap where other controls aren't sufficient or aren't yet in place. Read the SDS before choosing PPE. Before choosing any PPE for a chemical task, the safety data sheet must be consulted. Section 8, titled Exposure Controls and Personal Protection, lists the recommended PPE for that specific substance, including glove type, eye protection level, respiratory requirements, and body protection. Never assume that PPE used for one chemical is suitable for another. Even similar substances can require very different protective equipment. Hand and skin protection. Gloves are the most commonly used form of chemical PPE and also the most commonly misused. The material of the glove determines which substances it can resist and for how long. Nitrile gloves offer broad resistance and are suitable for many solvents, oils, and mild acids. Neoprene gloves cover a wider range, including some acids, bases, and fuels. Butyl rubber gloves are recommended for highly hazardous chemicals, such as ketones, esters, and concentrated acids. Two key factors to check are the breakthrough time and the permeation rate. Both values should be matched against the chemicals being handled and the duration of the task. Gloves should be inspected before every use and replaced immediately if torn, discolored, or showing signs of degradation. Eye and face protection. Safety glasses provide basic impact protection but offer limited defense against chemical splash. Chemical splash goggles form a seal around the eyes and are the right choice when there is any risk of liquid splashing or vapor exposure. Where the entire face is at risk, a full face shield should be worn over the goggles, not instead of them. Respiratory protection. Respiratory hazards are often invisible, making them one of the more serious risks in chemical handling. The type of protection required depends on the nature and concentration of the airborne hazard. Disposable dust masks are not suitable for chemical vapor protection. Half-face respirators fitted with the correct chemical cartridge protect against specific vapor types. Full-face respirators extend that protection to the eyes and are used where concentrations are higher. Supplied air respirators are reserved for environments where oxygen may be depleted or concentrations are immediately dangerous. A critical point to remember is that respiratory protection only works when it fits correctly. Fit testing is a regulatory requirement in many jurisdictions and must be completed before a respirator is put into service. Body and foot protection. For tasks involving corrosive chemicals or large volume transfers, the body needs protection beyond gloves. Chemical-resistant aprons are suitable where splash risk is moderate. Full chemical protective suits are used when total body exposure is possible, such as during spill response or handling highly toxic substances. Footwear should be chemical-resistant and cover the ankle at a minimum. If there is any risk of heavy containers falling, steel-toed boots with chemical-resistant uppers are the right choice. Donning, doffing, and disposal. Putting on and removing PPE correctly is just as important as selecting the right equipment. Contaminated PPE removed carelessly can transfer chemical residue to the skin, particularly the hands and face. The correct sequence is to remove the most contaminated outer layers first. Don't touching the outer surface, remove inner layers. Gloves last. Disposable PPE should never be reused. Reusable PPE must be decontaminated and inspected before being returned to service. PPE is the last line of defense. PPE does not make a task safe. It reduces the consequences of exposure if something goes wrong. It works best as part of a layered protection system where multiple controls are in place and PPE covers the residual risk that others cannot eliminate. When chemical hazards are properly understood, the right PPE becomes clear. And when it's selected correctly, fitted properly, and used consistently, it does exactly what it's designed to do: keep people safe.